And I think this is the post-lunch session, right? So normally we called in our everybody a post-lunch session is a sleeping session, right? But I hope that everybody will not sleep. Okay. If you have a very good lunch, then maybe you will get sleep. Uh, but let's see. We assume that you will stay interactive during the session, and I hope that the way we conducted in the last two sessions and the same way we'll try to conduct this session also. So the first two sessions we understand the motivations and the objective of the RIS, and we also understood that how we are going to mathematical analysis and formulations of the RIS system, how we are going to increase the capacity, range, extension, the physical layer security, and it's applicable to the cognitive radio and the UAV. So everywhere we have seen that the usefulness of the IRS, right? It will be benefited for the next generation wireless communication system, and that's a reason that it has that so many advantages. That's a reason that it is a strong conductor that for the 6G technology, and maybe the 6G and beyond. I can say that the futuristic technology, they may be going to use the intelligent reflecting surface for their communications, which can used for the uh, enhancing the range, okay, improve the energy efficiency, also improve the capacity and other BER performance also. So these sessions we'll see that is that we are the only one we are talking about, or all over the world, how many people or industry are working in this area? Are they going to developing this? Right? We'll discuss a little bit brief overview that how many people are working on this, and if anybody interested to do the work in the intelligence reflecting surface, then where that he's going to look, because everybody needs some kind of references to start with. So for that, they have to look for a prominent resource center. So to do these sessions, will mostly discuss this kind of things. So just to recap that the motivations behind the development of the intelligent reflecting surface, like we are talking about the virtual reality or augmented reality, and we are going to use this. Then the holographic teleportations, so telepresence, these kind of things required, right? High precision surface, okay, or maybe the cyber physical system or industrial automations, okay, additive manufacturing, all kind of things people are talking about. Those kind of things are different kind of requirement. So people are thinking that maybe that intelligent reflecting surface maybe that one of the technology which we can use. For that, I think this 5G has been proposed that enhance mobile broadband and also the ultra reliable low latency communications for IoT services, or maybe additive manufacturing, or maybe that massive type of communications, yeah, IoT services and the sensor network, or that people are talking about the very dense network, right? We can accommodate everything, especially if you see that intelligent transport system, right? Where that we need to control everything, the traffic. Okay, so all kind of things that people are talking in that, which is they are considered is the 5G technology, right? So new requirement is coming up, and as well as that we need to support the old requirement, right, which is the currently is coming. So we are looking at the futuristic, maybe 2030, right? What are the things is coming, which is talking about the 6G, right? So in that case, that what are the key parameters, right? So peak data rate, people are talking about the one terabits per second, right? So one terabit per second for the both indoor and outdoor connections. See, always you should remember that indoor and outdoor, okay, there is a at least 5 to 6 dB differences. So the moment we have a 5 to 6 dB differences, the data rate is also going to have a much impact due to the their BER and the modulation uses. So the 6G is talking about that, which is looking for the futuristic is the 2030. They are talking about the 100 and the 1,000 times that of the 5G. See, if you remember, when we have the objective of the 5G, it is 1,000 times than the 4G. Now 6G is talking about the 1,000 times of the 5G. User experience data rate. So this is very much important, that user experience data rate. Earlier we are talking about that what are the data rate is service provider is claiming, but it is not that what service provider is claiming. It is that what is the user experience, right? So user experience is should be greater than 1 Gbps for downlink and more than 500 Mbps for the uplink. So it's a 10 times. Bandwidth up to 10 gigahertz. It's not even the megahertz range. Especially the 10 gigahertz range is supported by the millimeter wave frequency band. And if you go for the terahertz, further that maybe that 100 gigahertz band we can reach. Energy efficiency 10 to 100 times of that 5G. Okay, so you can understand for every generation, our energy efficiency has to be increased 100 times, data rate has to increase by the 1,000 times, like that people are moving, right? So spectral efficiency 5 times of that 5G utilizing the available frequency spectrum, okay, more efficiently by the adopting advanced multi-antenna and the modulation technique. Connection density, that is, this is another important thing, right? To provide the dense network, right? Like you see that you have seen in the previous session that we can use the IRS in a room. It is not only the one, many IRS we can use, right? And different IRS, when we can use that, we can that IRS can support the multiple devices. So device, this is required because the connection density increases once you go for a higher generation, right? Now that in a particular, maybe if you see the 10 years before, we will have only a mobile, but now we don't have in the mobile. We have a mobile, we have a smartwatch, okay, we have a smart glass, we have a Wi-Fi connection, we have a Bluetooth connections. So even that, a particular human being, they will have a they carry the different kind of devices, right? So earlier it's a one, now it's maybe five, right? So the massive internet of everything, right? And the connection MTC, okay, massive machine type communications, which is the 10 times. Reliability, which is the greater than 99.9999%. So you see that almost 100%, right? There should not be any error, right? Like if you are going to consider for a additive manufacturing, you are making a product, if there is a kind of mistake happen, right, then this entire batch will have a problem. So that you will, when you are using this technology for the additive manufacturing, right, or maybe any medical, right, field, then there should not be any chance of, you should not get any chance for mistake. So reliability should play a very big role. That's the reason that people are closing that it's almost close to 100% reliable. Air interface latency, again, that it is not milliseconds, it came to microseconds. Because these things are required if you are going to apply the AR/VR system. Then the positioning accuracy, okay, so it is not that the 2D positioning, right? It's a 3D positioning, right? That because there is a lot of high rise there. So you are in the ground floor or you are in the 50th floor. How we will going to know, right? So now the GPS system is the moving from 2D to the 3D, and also that how much accuracy, right? Are you're accurate within the 100 meters or in the 50 meters, right? Then the mobility management, all kind of are people are talking about the 2030 vision. So this is that IRS can play a very big role, okay, to support all kind of KPI for the future generation, right? So this table is give a kind of a comparison between the two. Okay, so you see that mobility it can support 500 kilometer per hour to 1000 kilometer per hour, right? Because see nowadays a bullet train, if you are going to see the bullet train, right, the supporting the communication when the people are in the bullet train, so you need to have some kind of mechanism, some kind of technology which is going to support that. So IRS is actually can give you that, which is directly reshape the wireless propagation channel. We have seen in the last two sessions that we can really have a control, okay, over the wireless communication channel. Because in the wireless communication, we see the channel matrix H is one of the main thing which control the entire, okay, which impact the entire wireless communications. But so far we don't have a control on age, but using this IRS, we can say that we can control the age. The moment we can control the age, right, we can take the upper hand, we can exploit this, we can control, and along with that we can exploit it, okay, to improve the performance of the wireless communication system, right? We can think that we can go for the range extension, channel power and the rank improvement, channel statistical distribution refinement, right, interference mitigation, connection density enhancement, positioning accuracy improvement, all kind of things we can do, right, using the IRS. That we have seen that easily we can extend the range, easily we can make the rank of the channel, and we can change the Rayleigh fading statistics to the decision fading or other fading channel statistics. So depending on our requirement, right, we can actually, depending on the requirement, we can actually change the statistics of the communication, right? So that is the way that we can do. So this is we sometimes say confused about that RIs maybe that it's a similar kind of relay, but it's not. You see the relay means here amplify and forward and decode and forward this one. So when the sender sends, the relay receive the signal, then amplify it and send to the receiver. At the same time here that in the decode and forward, we receive the signal, decode and encode again and forward, right? So this is the scheme of the relay. So they are going to receive the signal from both the end, either direct and the reflected one. But normally in IRS, right, it is not like that. So that it is not required any kind of RF chain, but in the other cases where the amplify and forward or the decode and forward or the fixed duplexing, right, we always require a RF chain, right? Because that's why they are the active device, okay? Noise, it's not added any noise because we can control, but here that noise is there. Duplex, a full duplex, half duplex, and it is a full duplex. Okay, hardware cost is very low, medium, high, and very high, because you see here in the amplifying forward, it just needed to decode, because if you are not required to decode, so you will not have a decoder or encoder, all kind of hardware will not be available at the relay in case of the amplify and forward. But if you want to in DF system where that decode and forward, there we are going to have that on encoder, decoder, all kind of the hardware has to be there. Either you do hardware or software, but that hardware complexity has to be present in this. But in the RIS, these things is not there. Power consumption, okay, it's almost passive device. So the power consumption is not it will be very low, because in case of the amplifier you need to have a power amplifier, right? And you need to have a power who are activate the power amplifier. So transmit power, it is required. So that's why this power consumption is increases. More power consumption is required here. And decode again, because you need to function more activities. So it's required more power. So if you see the performance comparison between the all three, right? So RIS added network, you see here RIS added network, and the FD network, okay, and HD half duplex, okay, and HD delay, right? Half duplex and the full duplex. So you see that in case of the half duplex, the performance is almost same, right? But in case of the okay, in case of the full duplex, the performance almost same. Even that it is none depends on the number of RIS. So if you use the increase the number of RIS over a certain dB. So this is I'm telling that if you are using the power is 30 dB, if you are using the power is 25 dBm, then you see that up to a certain means if your number of RIS, if your number of RIS around 15, then the performance is below the full duplex and half duplex. But if your number of element increases, okay, if you're using more number of element, then the performance of our RIS is far better than the this all full duplex and half duplex. This is, if you see, we have seen in the earlier session that when the N is increases, the SNR is increases. So that is the that one of the number optimum number, that if you increases goes to the more than 23, right? Then the RIS enabled network is perform better than the full duplex and the half duplex, right? So it is not that you are going to use the only single element or two elements. Okay, it's not like that. You have to have a sufficient number of elements need to be used. So then only you can get the performance, okay, improvement than other existing communication network. Now, if you go on to that, so this element, if you think in a different way, so we can consider this all element will be an antenna, right? Because they are reflecting, right? So we need to compare with the massive MIMO. Now, if you go to the massive MIMO, how we are going to use in the massive MIMO, right? So area, it's implemented maybe millimeter wave frequency region, shorter wavelength, which can go for the smaller antenna size. So allow large number of antennas at a single terminal. That is the advantage of the massive MIMO. See, massive MIMO you cannot use actually that is the at the frequency where that we are using GSM, right? Maybe 1 gigahertz. That there you cannot use the massive MIMO because it's limited by the antenna size, right? So if you go to the millimeter wave, you can use the number of antennas. So area power density, right? So where that for 5G it's a 10, 4G is just giving a comparison, right? How we are going to use the different kind of technology, right? So always you need to know that how from where we have improved, okay, and how much we have reached. Now, if you compare the massive MIMO to the RIS, right? So this is the way that massive MIMO that we require the RF chain, okay? RF chain is needed for the more active and for the more active component use, and no RF chain is required because that due to the passive reflection only, right? So and because of this, they have used the active antenna and maybe the power amplifier, all kind of things they are using in case of the massive MIMO, That's why they increase the energy consumption. And in case of the IRS, they are a very low energy consumption because they are not going to use any kind of power amplifier. In a communications, if you are going to see that a communications mainly the most of the time the power consumption is dominated by the transmit power and transmit power, and it is depends on the power amplifier. So power amplifier is plays a very important role on the power in a power consumption. So that's the reason that if you are using the power amplifier, okay, in a communication, then your energy consumption is definitely going to increase. Then the hardware cost, because you are using the massive MIMO, using the more RF chain, so hardware cost processing will increase. For that, it's a scalable, and the scalable cost and the complexity also scalable, because how many elements you are going to use. Okay, so what should be your size of the RIS, that is going to give the increase the complexity. So I can scalable, like either I can use a very high value large size of the RIS, or maybe I can use the few small size of the RIS. So that depends on the cost and on the complexity. Because if you are going to make a very large size of the RIS, maybe its cost will be high. But if you are going to use a very small size, okay, maybe you can use a maybe I can say maybe 30 into 30 cross 30, or maybe you are going to use a 1000 cross 1000, right? So all that depends on the, it's scalable the cost, because we have seen in the previous that even that if you use that many number of small RIS, still it will you are going to get a similar performance. So why should we use a large size of IRS, right? It's better that we should use a small size of IRS. So implementation is challenging due to the active component, and it can be placed anywhere, right? So maybe in the building, right, you can just, like if you remember that 3D printing, right, maybe it's possible will come that you can design, you can print a RIS and using the 3D printer and just paste on the wall, right? You need not to do any other things. So now we see that what the industry is working on it, or what are the research collaboration, research group is working on this RIS, right? It is that only that few people are working, or really it is really a very the futuristic technology that many people are working on it. Let's see. So it started working on 2012, right? When people are started talking NSF USA in 2012, they had a one project called the manipulating terahertz waves using three-dimensional metamaterials. So they want to see that what is the performance of the metamaterials device on the terahertz. So for this is I can say this is the starting point of that people thinking about that, yes, we can have a reflector for our communications. Then there is another things that people really thinking about, that about the IRS, okay, that which is that 2017 to 2022 they have a visor SAF, okay, is the proposed the hardware and software platform, the hyper surface that separate the usability concern from the underlying physics. Like they have used the meta surface and artificial material that whose electromagnetic properties depends on their internal structure. If you remember that we told that electromagnetic properties can be can be changed, right? By either it will be reflected by changing the impedance and other parameters of the metamaterials. So this is the thing that people have seen, that can this be utilized, right? And it can be used for the steer the things, like you see that we can absorb and the steer the incoming direction and the frequency, or the incoming and outgoing direction and frequency that we can know. So these people have started that, okay, maybe this will be very much useful when you are going for the IoT applications, right? So things have started from that. Then slowly that entity Docomo, they have found very interesting, right? Then they have developed, okay, demonstrate the 5G mobile communication system in 20 gigahertz band, okay, in the 5G, the first meta structure reflect array technology. So this is the IRS they have used as a reflector, okay, they placed on above a vehicles and they try to reflect, right? So they are with the company which is called the MetaWave, okay. So they placed and they try to see that how much data rate they can gather, okay. So they have seen the communication speed they have achieved was about the 560 Mbps, okay, compared to 60 Mbps with no reflector. So that is this is the first the implementations people have seen that you see that almost 100 times, okay, simple reflector can increase, okay, simple reflector can increase the speed of the communications, right? So if you remember that I think at the beginning there is a call of photophone, right? The communication which is going to be sent using the light, okay. So that is the starting point of the optical fiber. So this is, and that is also work a mirror they have placed, okay. Graham Bell placed a mirror and they just send, okay, you just send the light wave, and he thought that within the light wave he can send some data and it will be reflected, I can receive. So this is also electromagnetic wave. Now these things came in a different form, right? Which can say that in a reflector. Okay, so but this is the first anti-Docomo. Then another project did Adrian, which is they had a three pillars. So second pillar, three objective. Pillar means is objective. So they have a second objective. They are telling that communication beyond the Shannon paradigm by means of the meta surface. Okay, for the non-LOS or abstracted LOS connectivity. Okay, so when we have an obstruction, how we can, like you see this is the room. In this room, if there is an obstruction, how we are going to communicate, right? So they had a one objective, okay, among the three pillars, the communication beyond. So this is the first thing they have started. So you can search in internet, you can got these all projects, and everywhere you will find they have a delivery, some project reports, right? When we have get some project reports, you can understand that what are the channel they have considered, how they have analyzed, and what are the performance they got. Then another company that who has used the these two company is actually Tower Jet and the Lumoti. Okay, this is a very interesting. They had a made a device, right? And they are telling that this is a holographic beamformer. Okay, so they are sending through the light. Okay, so this is the concept they have used the holographic beamforming by building the miniature metal structure on the surface. Okay, and this is possible to change the refractive index of the surface. So this is way that they have used. Okay. Next is the scaling, another project which is still running by the NSF. Okay, the scaling WN to the terabit per second, the terahertz spectrum architecture and the control. So the first project first provides the two underlying building blocks of the steerable and highly directional beams from 100 gigahertz to 500 gigahertz. If you remember that 100 gigahertz is the starting point or end of the millimeter wave, then people are moving to the terahertz communications. So 100 gigahertz to the millimeter wave to the terahertz communications, how we are going to do, that is the project people have started. So there is also people have started using the meta surface. Okay, new smart reflecting surface will be developed that will enable engineer non-specular and non-line of sight path. So this thrust is experimental study the achievable network density under different architectural component. So it will provide the terabit per second scale communications in the presence of user and the environmental mobility. Another company which is the Meta Wireless. Okay, this is the another project group Okay, this is done by the European Union, Horizon 2020. They had a group. They have the one group is research group is working with the consortium of the different company and different research institute, which is called the Future Wireless Communication, empowered by the reconfigurable intelligent meta materials. So it will be there the theoretical algorithm and architecture, and their object foundation to the RIS enabled future wireless, and their objective is to developing RIS theoretical framework, algorithm framework, and they have to go for system level simulator. So maybe after 2024, you will get a simulator who can simulate the reconfigurable intelligent metasurface based wireless network. So if you go in the web page of the Meta Wireless, you can get a lot of deliverables. That deliverable can be very much useful for your the research work. Then there is another company, okay, that is telling that holographic beamforming requires only a single, simple, and a biased control component. Okay, so that based control component like varactor, okay, and a transistor at the edge element. This leads to the cost advantage about 50x against MIMO and the phased array. So we see that this is a radiating element we can get free space side, and the other side we are getting the tuning element. So this is way that we can actually control. So they have designed this and which will be useful. Okay, so is it possible to validate the meta surface at the terahertz in India? Okay, in IIIT-B, I don't think so that it is possible at this moment, because people are working, and I don't think that we have any kind of simulated environment. Okay, maybe Professor Das can tell about. So Priyanka, do you have anything in the IIIT-B? Okay, maybe in the next session we can ask this question.
Yes, so
yeah.
So right now we don't have IRS setup, but we hope to do within next 4 to 5 years.
Yeah, so I think that 2024 we'll get.
Hopefully.
Okay.
If we get good research students provided.
Yeah, that is another important thing. Yeah, good research students, right? We have a project, so if you are interested to do the work on the IRS, you can definitely contact us. Okay, so then I think with the help of you, we can do that. Okay, so NTT Docomo again, they have done a reflector, but with the help of the AGC, they want to make some kind of IC. Okay, so 28 gigahertz they have already made, and there I see they are still working to improve the things. So they have made a collaboration with the AGC. This is another company, and making the different kind of devices, prototype, right, which can be like, you see, this is a one kind of prototype. Okay, so it's like a window, right, but it is not a window. This is very interesting, right? Maybe future you can see that you are not going to purchase a window glass. Instead of, you are going to purchase a IRS, right, which will be completely replace the window, and we can get the whole communication. Then there is another project, okay, funded by the NSF. Okay, I'm just here mentioning the how many different group are working, right? Because that is the objective of the session, so that anybody is interested to work on this, okay, definitely visit this the search in the Google. They will land to that particular website. In some cases you may not get, but maximum cases you will get the information. Okay. So this is also that the configured reflecting surface 2021 to 23. Yeah, so they have a research to cross-layer design, analysis, deployment, optimization. Okay, everything they are going to do it. Then the Pathfinder. Okay, this is another project. Okay, it started from the May 2021 to 23. Okay, and this is, I think, European Union. So harnessing the multipath propagation of the wireless network, a meta surface transformation of wireless network into a smart reconfigurable radio environment. So you see that that it is not that a few people, it is the entire world. Many people are working. Like their objective is the physics inspired model, because many paper you have seen today, we have discussed, we have taken references. They are the result of these projects. Okay, so people are working who are worked in this project, they have published their findings, and we have also used that some of the papers when we discuss the performance, okay, analysis of the RIS. Then another, the Horizon 2020. Okay, they have one project called the RISE 6G. Okay, so this is the reconfigurable intelligent sustainable environment for 6G wireless communication network. So this is the objective of that. This is the project title of this RISE 6G. RISE means RISE, RISE 6G. So this is the they are different working group. Okay, so I just try to see that how many information is available to give you a realistic picture. Okay, so they have a different kind of working group, working that different kind of component, right? One is the project management, one is the scenario and use cases, one is the enhanced connectivity, then the modeling, evaluation, dissemination and standardization. Okay, then the localization and sensing and sustainability, all kind of things they have used. They have a different working group, they are working on it. Then another project, which is the 2022 and 2024, which is the surface wave in smart radio frequency environment. Okay, so they are also working in this. Okay, so they are talking about the surface wave communications. AGC, earlier it's worked with the entity, and it is also now in a partnership with the Greenwave, and they are making the RIS, right? You see, this is the very nice looking RIS, right, which is can work. So develop the RIS reflector that can be installed on the indoor wall and the ceiling to switch the direction of the radio wave, and thus improve the indoor area is the 5G millimeter wave communications. So AGC has a partnership with the Green Wave of the France developed the RIS reflector, utilizing the AGC core technology. So this is the summary of that. Whatever I told, I just see that how many different type of things they have. See the funding. There is also funding has been mentioned here, right? You see, it started with this. Now funding is this much European, right? Which is the sulfur having the this much European project. So meta wireless, you see, this is the value of the project. So many people are working in this field, right? So, and this is many people are working. You see that all projects are started in, maximum projects started in 2020, 21, right? Not yet completed. So this is a very good area to do the research. Okay, those who are interested to the research, they can take up this this IRS for their research work, because it is not many people are working, but I'm telling you, it is a relatively new area. Although you can see that there are many research group are working, but compared to the whole research, this is a very teeny amount. So even that, if you want to do the work, research work, you can choose IRS is one of the research area where you can concentrate, and you can do a very good work. There is ample opportunities are there, right? Because not many people are started working, and all people are working. You see that everything started in the July 2020. See 25, 23, 24, 23. 23, 23. This is the end date. So that means project will complete in 2024. So you have a ample time. see here is also, even that is the 2020, it will end is. So all the project, I think it's listed around the 10, but all the project will end almost. I think this is only, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Out of 11, okay, 8 projects are not yet completed. That's the reason this is a very niche area and very futuristic area and relatively new area. Okay.
Sir, can you just elaborate from Indian perspective? Are there anything going on among these projects?
Indian perspective means not many people, but I don't have a data on that from Indian perspective. Okay, so maybe that if you have, you can, right? People are working, but it's not they formed a collaboration and working in this. Okay, so see, individual researchers are working, right? But the individual researcher, they are not forming a collaboration and working in this way. Okay, from that, like European, we have a project. Okay, they had a consortium, but I did not find any across any kind of DST project or the MIT project who are concentrated on this. Maybe this advanced communication system, they can do that.
Sir, we have actually called for proposals in this area also.
Yeah, I mean, a call for proposal is there, but
so we will be funding. We will be funding projects by the end of this month or hopefully next month.
Yes, yes, that is. I'm telling that
that will be a collaborative effort.
Yeah,
yeah, it is about to start. Yes,
it is about to start. So
yes,
here I mentioned that which project is already been started. Okay, so that's what I'm telling. Maybe this IIIT comment, they have a call for proposal for the RIS. So once it will start, maybe those who are interested to join in the IRS, working in the IRS, they can just look for, just visit the web page of the comment. So once this project comments, you can apply that, because obviously they will be need a lot of research scholar. So you can apply, and if you are really interested, you can get a chance to work. I think that is the word that Professor Priyanka was telling, that maybe 3 years down the line, we may have our own simulator on the IRS. Okay, that's right, right? Okay, so moving ahead. So this is another that this is the very futuristic. Okay, still people have started working that holographic MIMO surface. So this is a very interesting one, that if you see the holographic telepresence, all kind of things, right? So this is a starting point. Like we are telling the electromagnetic wave. Now instead of electromagnetic wave, that if we have a use the electromagnetic wave, and if we represent in the holographic, right, wave, so that then the things will be more interesting. Right, so people are working in that, and I think this is a very very interesting things, right? If you have a interest on the holography and the computer generated holography, you can look into these things. This is also one of the applications of the intelligent reflecting surface. So you see that how exactly we can do the holographic in the beam forming, right? Holographic MIMO, right? Age MIMO. This is just I just give you a scenario. For more, you can see the references is given, right? You see that this is the paper is it's a wireless communication in 2020, right? And not many people. I think that only one group is working on this. So if you are interested, you can do this also. Finally, that people are using now it's a real design, that one bit unit cell design. So RI is command 160, 16 into 10 unit cell. The radio frequency, okay, so this is the metallic patch, radio frequency, RF chain, pin diode, switch, and the biasing line. This is, you can see that how the things are looks. So this will be a see the size 414 millimeter, and this is a 259 millimeter. And if you see the how many elements are there, 1 2 3 4 5 6 7 8 9 10. So 10 cross, I think 16 cross 10. Yeah, sorry, I didn't count. 16 cross 10 unit they have designed here, and you see that how they have designed everything is mentioned here. Okay, so this is, you see, another one, that how the RIS front end looks like, and RIS back end is looks like. So one is the tuning parameter and one is the reflector. And this you understand that this is a, you work in the sub 6 gigahertz band, right? Which is our normal communication band. Okay, so 5 gigahertz around. So but this can, so that we can place this reflector in our window, on our ceiling, okay, in the side wall, and we can use our mobile communication, like the 5G communication it is. Okay, so with that, I think I am concluding these sessions.